Good afternoon, everybody. It is a pleasure to welcome you back this afternoon. But my great pleasure this afternoon is introducing this next panel and its moderator. Artemis Westenberg will be moderating the Designing Living Space on Mars. And she is not only my colleague, she is President Emeritus of Explore Mars. She is CEO of Explore Mars Europe. She is inspiring people not only in the Janet's Planet Astronaut Academy, but also as the CFO of the Mars Moon Astronaut Academy and Research Science Foundation, along with Dr. Susan Ipjewel. I am very proud of this fact. She received a royal honor from the Dutch country of the Netherlands, and it is an order of chivalry recognizing people who deserve appreciation and recognition. I'm sure I didn't get that entirely correct, from society for the special way in which they've carried out their activities. Artemis has joined Carbon Capture Coatings in a consultancy capacity with the aim of harvesting CO2 and nitrogen from the atmosphere with the help of algae. Her vast resume spans many years. She started and helped co-found Explore Mars 10 years ago, and has just been this wonderful proponent, fluent in 5 languages. And one of the wonderful things she's done for me in the last 18 months is that when the world locked down, she said yes, and she has been co-teaching and team teaching with me since that moment. And we feel very proud of that work. And there is an Artemis, help me with this word. It is a Hebrew word called hesed. Hesed. And it basically embodies this feeling of loving kindness. And that is what Artemis has done for many children and adults all along her kind of luminous career, but especially to me in this last 18 months. I consider her not only one of the smartest women I know, but I count her among my dearest friends. Artemis, we can't wait for this great panel. Thank you for being here today.
I'm happy to be here too. Now, my question to you as an audience is, do you dream about your ideal house on Mars? I do. When thinking of living on Mars, I envision the northern rim of a crater, a cliff house, mostly buried into that crater rim, a bit overhanging crater rim on the roof of my house for protection against cosmic radiation, meteorite impacts, but with unimpeded views of the golden desert that is Mars. Now, I dream big, so my crater rim house is a penthouse on 3 floors, having large windows on each of its floors, and I surely hope that the engineers can, engineer that for me, because I want shielding, but also these unimpeded views. Now, as a historian, I realize that my dream is no doubt influenced by the facades of Petra in Jordan, but also actually of the Earthships that we build on Earth today. Sustainable, ecological housing with human well-being and health at its center. That is my dream. Now, the panel today dares to dream big while taking the constraints of both architecture and Mars into consideration. They will take us to how living, and emphasis here on living, on Mars can be done. They strive to give solutions to what NASA and other space agencies are missing in architecture. The panel talks about architecture in the long run, so in the far future, but also in what steps they will build this housing working environment on our second planet that will benefit our minds as well as our bodies. Each of the panel members will introduce us to their take on what constitutes good living on Mars. And I have the pleasure to start with Michal Ziso. As an architect, Michal set out to create a symbiosis, innovation, and equality to enable us to thrive. She founded Ziso Architects because of the knowledge that the built environment has an effect on our behavior, our choices, and our feelings. She is a proponent of designing future architecture with equality in mind, all in order to maximize the human experience and the performance on Earth and in space. In her own words, it's time to shift our focus to how to live on Mars rather than how not to die there. Michal, take us to your vision.
Thank you so much for this amazing presentation and introduction, Artemis. I will be sharing my screen. 1 second. Can you see it? So yes. It is my absolute pleasure to be here for a second time on the Humans to Mars Summit. I am representing Ziso. We are an architecture and innovation lab where we imagine, design, and create the future of the built environment. We inhabit the intersection of architecture, innovation, space, and human equality. I am architect Michal Ziso. I am the founder and CEO. I am the graduate of the Technion, Israeli Institute of Technology, as well as the International Space University. I am a public speaker, a 2-time TEDx speaker, one of which at the International Space University, a futurist, a visionary, and a space architect, which basically means that I love to think about how will living environments for humans will look like outside of Earth. It can be anywhere from spaceships, like the ISS, to the moon, to Mars, and beyond. We are focusing on projects that are not only the top of technology, but also kinds of projects that will enable diversity of humans to perform their best. My specialty on Earth is skyscrapers and large-scale projects, and we're also focusing on a lot of research about closed-loop environments in extreme, closed-loop systems in extreme environments. So for me, if I think about why architecture has the possibility to influence the way we think, the way we feel, and even the way we behave. If the architecture we live in is good, it has the ability to enhance our performance and to make us happier and also to better our well-being. But if the architecture and the living and the built environment was not designed for us, it has a bad impact on our life. It can make us feel uncomfortable and even unsafe. So when I looked around and I started to research, I realized that our world is changing very, very quickly. If it's technology or social structure or even our own personal needs and wants. And as opposed to that, architecture on Earth moves very, very slowly. Things take time to change and to adjust to the changes of the world. And this gap is a real issue. And for me, I found that space architecture is a way to go through a process of unlearning. That means that we can forget by looking at Mars, for example, we can forget and the architecture we have on Earth because we have no choice. We have to think about how we design completely new architectural building blocks. And also it gives us a chance to connect to vernacular architecture, which means that it is organic, coming from the grounds, from the location that we are at, designed for the people that will be using the specific architecture. I'm also honored that my studio has been chosen in 2019 to be one of 10 initiatives by the SDGs, the UN Social Development Goals, as part of Action Partners campaign. And Mars specifically is so extreme and so far away and so complicated, but its challenges, its problems are actually are looked as opportunities to really think about how we can create an environment for a very diverse group of people. And also it gives us an opportunity to think about how we can expect multiple possible futures. A lot of things can happen on our way to Mars and when we get there, and we have to be prepared for multiple options. So a few of our, I'll show just really briefly 2 projects. One is the settlement that I designed on Mars. It's called Mars is More. And it gave me the opportunity to really think about how we can design with equality in mind. Now, closed loop systems means that we are completely self-reliant. We can produce our own energy, our food, and also have a controlled environment. But there we have to do it in a sustainable and efficient way, We can use anything from inflatable structures to 3D printing to reusable. It has to be light and quick and controlled, using local materials, and it has to be safe. Not only safe to make the people, like Artemis said, not die, but also to make them be more efficient and make their well-being be much more evident. Another project that I just want to show quickly is another closed loop system that I designed on Earth in extreme conditions, in an extreme environment in the US desert in Nevada for Burning Man. And here we chose to use many types of rings that can help us to create and to produce all the things that we need, including to produce our own food. So today we are researching a few things in the studio. We're researching space habitability via analog habitats on Earth. We're researching Earth disabilities transforming into space superpowers. We're also looking into personal space, pun intended. We're thinking that in space on Mars, people will have to live in very small quarters and with diverse people that are different than them. And it's a very different kind of perspective, how we think is a comfortable personal space for each individual. And the fourth thing is I'm continuing a research with ISU and the International Space University about intercontinental suborbital commercial liner. Our mission, like I said at the beginning, is to enhance human health and performance in space using the design and architecture of the built environment. And collaboration is key, so I'm so happy to be here and hear my colleagues right here. So thank you so much, and I will give the floor to my next space architect.
Yes, well, now it is, thank you, Michal. It's now my pleasure to introduce to you Alfredo Munoz. He is founder of the Abiboo studios in the USA, Spain, and India. Abiboo is providing cities on Earth with what I would call architectural fluid buildings and urban planning. I would recommend that you visit the Abiboo website to enjoy the amazing visions of cities all over. Now, Alfredo is also a board member of the Sustainable Off-World Network, which believes that having humans live on Mars will enhance international cooperation, it will boost research and innovation, and help us find creative solutions to Earth's problems. Alfredo has two passions, architecture and astrophysics. And designing a sustainable city seems kind of logic for someone with those passions. For 1 million people, no less, big city on the red planet, and it brings his two passions together. Alfredo, take us to our city on Mars.
Thank you, Artemis. Thank you so much. So Artemis already gave a little bit of the background that I had. Originally from Spain, I educated myself as an architect, but I had the fortune to work and live in 5 different continents. And that added a lot of value when we started to consider what will be the challenges that we will need to design on Mars. Because not only Mars requires a multicultural approach, but also a multidisciplinary approach. And that's where SONET comes into play. SONET is a group of multidisciplinary experts, mainly from Europe, but also from the US, that we came together with the objective to create self-sufficient and sustainable settlements of world. Today, I'm going to be showing you just one example that we did for Mars. We call it NUWA, and it is intended to be a self-sufficient city on Mars, as Artemis mentioned, for 1 million people. But what does it consist of? Well, it's a vertical city that is located in a cliff on Mars. And the key aspect of it is that it is self-sufficient. The reason for this is that we cannot really consider building a city without using the resources on Mars. It's not only unsustainable, but also it's not is not scalable. Why is that? Because we only have a window of opportunity of 1 month every 2 years to bring things back and forth from Earth to Mars. So we need to build with local resources. And it's also important that if it's going to be a permanent city, it has to have a sense of identity, a sense of belonging for its citizens. That is very different if we compare a permanent city with a temporal settlement where we know the astronauts are going to come back and forth. So for us, it was essential not only to solve the safety of the citizens on Mars, but also to create places that are habitable. That has to do with how we envision the main construction solutions on the city, and that is through tunneling. The advantage that we have with tunnels is that they provide a safe environment protecting us from many of the challenges on Mars, but at the same time, they create a community and allow for indirect light from the vertical sides of the cliffs or canyons that we are proposing. The scalability comes with a macro building. We are calling this a structure that is a mixed-use solution. It includes all the day-to-day activities that the future Martians will need to live on Mars. And once the complete macro building is finished, we can go ahead and continue with the next macro building. So it's highly scalable, which again, it's important in order to bring a feasible solution that is associated with living on Mars. And here you can see some brief visuals of some of the spaces that are associated with the city. On a typical cliff, we have the vertical wall, then we have the mesa, which is at the top part of the cliff, and then we have the valley, which is at the lower part. In Newark, we are taking over all the three aspects of the vertical city. Inside the cliff, in the vertical wall, we have the views that you see on the lower corner. But then on the valley, we propose the farming, which is critical for ensuring that humans will have the proper food. We also have the energy generation. That is an advantage because at the top part of the cliff, we don't really have the challenges of the need for protecting the spaces from the radiation because people are not going to be able to walk in those spaces. And then at the lower part of the cliff in the valley, we have communal areas, which are spaces that might be larger where we can actually interact in the community and in the city. But building on Mars is very expensive. Not only it's expensive to build, but it's expensive to maintain. So we need to find a very efficient solution that not only provides a community, but at the same time is containing a space. So here you can see some comparisons of areas. So we have around 170 square meters per person. If we compare with Manhattan, if we look at all the built spaces, including the streets and the parks, we estimate that is around 130 square meters per person. That means that the city will be a little bit less dense than Manhattan itself. But then we have other areas that are not suitable for humans, mainly for farming, which is 110 square meters per person. This is fascinating because if we compare with Earth, on Earth, we use 6,000 square meters per person. That indicates that if we bring the technology that we have nowadays, we can bring a huge amount of innovation and change for good in order to help with climate change. Here, you can see some strategies that we are doing for the resiliency of the cities. As Artemis mentioned, we are proposing an entire colony of 1 million people, but we are dividing it in 5 different cities. That is in order to ensure resiliency. In case there is any problem in one city, we can always go to another city. And also, as I said from the beginning, in order to be able to find the local resources that will be critical to ensure self-sufficiency. And Mars does not have all the resources that we need for entire colony in one location. So by splitting it in different locations, we are able to actually be able to leverage those resources locally. And here you can see Newark, which is located in Tempe Mensa, Avalos Cities, which is located in the north, to be able to mine ice. And then on the lower part, you can see some other proposals. And I'm going to show you now a video of the team. Hi, I do architecture and urban planning.
I do conveying.
I do future scenarios.
I do architecture and graphic design.
Life support systems.
Chemical engineering.
space psychology.
I do architecture.
Mining and rock mechanics.
Fashion and art.
I'm an astrophysicist.
Architecture.
Astrodynamics.
In-situ resource utilization and manufacture.
Architecture.
Brain-computer interfaces.
Space engineering.
Architecture.
Planetary geology and geochemistry.
I do economics with fish.
I do planets.
I do rocket science, and we are Sonnet.
Amount of value, and that we hope that it's incorporated in the next decades to come.
Okay. Well, thank you, Alfredo. So then to the last, but certainly not the least of this panel. Vera Mulyani is a movie maker, a writer of children's books, next to being a French-trained architect who, finding fault with Manhattan's urban design, wrote the book F the Rules. If this were the Netherlands, I could actually say the word, but you can't do that in America. Vera proposes the concept of recycling cities, which is to say, transforming damaged areas caused by industrialization into sustainable green zones to better integrate the natural environment into human living spaces. Vera is, next to all that, also the founder and CEO of Mars City Design, exploring livability and sustainability on Mars. Vera, show us what livability looks like on Mars, please.
Yes, thank you. Before I start the video, I just want to thank you again for Explore Mars for hosting me and my two fellows, very incredible, talented, courageous architects, like real architects, because we do earn this. You know, it's not like we just suddenly show up from nowhere and we become an architect. It's a hard work. We don't sleep, we don't eat. Sometimes we just drink coffee and whiskey when we celebrate the success. But so I think each of us have a story, and the childhood story that is very marking to your identity, just like what Alfredo mentioned about his architecture. And mine would be about the Black River that helped me to realize that there is the big system behind everything that we are living with every day. And that big system is Mother Nature. And when it's aching, we are part of that Mother Nature that will be also struggling to survive. And I think a lot of people mention why Mars, the Earth is dying somehow. I think the answer is because Mars is the out-of-the-box solution for us to be able to handle and also find a root cause of all these disease that we are facing right now in society, but that cause Mother Nature to struggle, continuing. So today, before I start this visualization, I just want to use this time to not to show off what our design competition winners could do or could not do at Mars City Design. There are big names of architects who can do that better than us, but I'd like to offer my voice about considering our position within the space mission planning. We are a community of visionaries. We are trained to see far, to close distance of where and how human destinations could be. We have desires to advance. We see our context, and not just, space in terms of environment and place, but also context of time. We observe, we understand that those places want and desire something to be connected to the human destiny. Where are we at our timeline? And we design the paths towards that vision. That is how our design process works. It works like a human body. You see, we have a brain to think, well, some of us do. We have eyes to see and our feet to walk and run. The point is that each body part is designed to fulfill our desire and perform its function. And together they realize our story, our life experiences and journey that are beyond just what each part of the body can do. So the collective young generation's desire has always been, actually, to go to space, to reach the galaxy, and to leverage the moon to make Mars a second home for human living. What is available today in the space industry is much better for us compared to 5 years ago when I just started Mars City Design for creative visionaries. But we're still not very much included. We're pretty much here to accommodate the existing infrastructure that, in my opinion, is not sustainable yet. Because as if the brain has to adapt to the feet. So Mars City Design community, we are visionaries. We see holistic aspects of what it is for humans to occupy Mars. But each time we somehow have to deal with the limitation that is not aligned with the vision. I just want to take an example of the beautiful design that Abiboo showed, for example. If we want to realize that on Mars, we will have to face the planetary protection, for example, right? Just a simple thing. So that is an example. So it's just like a marathon runner interrupted during his race because the day before he ate a bad curry, for example. And the stomach says, hey, we need to go to the loo now. So this is an analogy to Earthers who are not open to the Mars projects. But other most limiting examples would be that the fact that some space leaders would launch programs that are also based on only problem solving. We understand that is how economy works. Our eyes are designed to see, not to walk or run. But we need both eyes and feet and the ensemble of our body to walk to a direction that is aligned with our mind. It all happened in milliseconds. But the point is that we visionaries have our function too. To not include us in the planning of your big mission is limiting the problem solving itself. You're just surviving, solving problems, treating symptoms instead of finding the root cause and go beyond overcoming. So there is a secret treasure behind every dirt or difficulties. That is nature's design. So the message I want to convey today, have a holistic vision to conduct your planning. If you are not designed to do that, please include us visionaries in the team. Don't just take their design and run with it like many do. There are contexts associated with each step and each design that we make. You can take and copy and run with it, but perhaps even make money, but you're not helpful for the initial purpose of that design mission, the big picture, which at the end makes what you do excluded from the big plan that nature has. What does nature do to that at the end? I believe eliminate it, because it becomes a foreign agent like cancer to the whole body of nature design. So do include the visionaries in your project, not to copy our work. And here are the examples of how, from fantasy, inspiration, concept and vision, story, perhaps still far from reality for today, but we can evolve these projects to be more pragmatic, practical, to solving urgent problems on Earth. I believe visionary projects can solve immediate problems, but immediate problem-solving methods usually don't only creates new other problems that are not conducive with the holistic vision. And forgive my whole voice. So this is the example of a design by Karen Gandhi, Neurosynthesis, in 2016, that have grown into the next design in 2019. We envision the domes that each junction has a room, and we're using this for astronaut training. And of course, many of you may have seen this by Mohammed Ahmed, Mars Spine. It was the winner of 2020, as well as Giuseppe Calabrese's introducing how we can use the robotic system to build the greenhouse before humans arrive. And this is a 2019 version of Living in the Cliff that was designed by Sylvain Trouillman from Paris. And he directly referred to the Petra in Jordan, also show how the city could be built with the intention of sport activities. And it was in the context of Mars Olympic design. None of these are new in human architecture design. This is ancient method that humans use when we still respect nature when we design. And finally, our Alpha 2.0 that we submitted to the NASA 3D printing competition that promotes the plant-based material and water recycling. And this is for mental health of the astronauts training. We have this cabin as a real project that has been patented. And finally, our clean fuel facility that is in the process of design. We are including actual technology that NASA has, the kilo power, and just train ourselves to design the methods, the first path to really build our city. These are hydrogen rovers. That's it. Thank you so much.
Okay, thank you, Vera. Now, I think from what you just saw, my dear audience, you will understand that the aim of this panel is to look further into the future than most of the panels at this H2M. But our aim here in this panel is also to look not just at the end goals, but also at the interim steps to get there. And so I have a couple of questions for the panel, and I also see, and I'm very delighted that you, the audience, are sending in questions, which I can see in the chat. So I will try to incorporate your questions as well. Now, one of the first things that I would like you to answer me, on the surface buildings or underground structures, what's your choice and why? And I'm starting with Michal.
Can you on underground or on the surface? I mean, yes. I think that if we're looking into, like you said in the beginning, to well-being, I think underground has a lot of issues in terms of psychological aspects of humans. Yes, it is a very good way to kind of prevent radiation to infiltrate the habitat. But I think living underground without actual connection to the outside world is a big issue. I think the solution will probably be a hybrid. Parts of the day maybe will be underground or inside the wall of a cliff, but parts of the day we will have to have some sort of connection to the outside world. And then again, there are other options to prevent or to protect the habitat from radiation, like using water walls, ice, things like that. So this is not the only option. It's a very interesting option, but I think that it's something that we shouldn't get used to from the get-go, even if maybe it's the immediate idea because of the psychological aspects.
Okay, Alfredo, Vera, do you both concur with that?
I would like to add something to what Michal mentioned. I think it's both, and it depends on what is the objective and the timelines. So for large buildings on the surface don't really work that well. Indeed, on Mars, we are all very familiar with the challenge of radiation, but one of the other challenges that are not that common to know is indeed the pressure from inside of the buildings, because the pressure difference is so high between the inside and the outside. If we build buildings on the surface and those buildings are very large, the exponential pressure from the inside will try to break apart the building. The skin will rip off. The structure will require so much material that is not really sustainable or doable on an economical term. So from the economical point of view and sustainability point of view, having really large buildings on the surface of Mars does not seem to be a right approach. At the same time, the advantages that we have underground is that the thermal inertia of the rock, or if we go underground, helps a lot with the temperatures that we have on Mars, which many of you might know. Depending on the area, it's even on the warmer days can be as cold as Antarctica. So in that sense, being able to have a lot of mass around the spaces that are habitable helps to, again, be able to develop a sustainable solution for Mars. But as Michal very rightly identified, there are problems with well-being. If we are fully underground, we don't have access to light, which is critical for permanent settlements. So at the same time, being on underground solutions, if we don't go with areas that are already built there, like lava tubes, can be expensive and time consuming. So probably the first settlers on Mars will be on the ground. But on the long term, from my personal opinion, and based on all the work that all the group of experts that we did with Nuwa and some other work, seems like probably it's not the best solution to go on the ground. So as Michal was saying, I agree with her that probably a combination of both can be the right to go here.
Absolutely. I think it depends on the time, the context, but what's fascinating with the fact that there is less gravity, activities will be different, and furniture not going to be designed like how IKEA is. Will be really interesting to think about connections in the three-dimensional, even four-dimensional interior, or the design that we will live in. Because at the end of the day, it may not be any kind of form that is permanent. It should be evolving, and it's really, really cold on Mars, right? I mean, how do you power all the energy for the underground base? But also, if needed, perhaps to protect us from radiation, if we have to live underground and to solve the psychological issues, then we need a way to introduce some new technology like pixels that are screening the outside view, for example, as an alternative windows. But this is really isolating, again, partially problems, instead of looking at how the city will be designed, and then we go to micro. But that's just an example.
Okay. Now, my next question is, you're designing for humans, specifically you're saying, all the technicalities, all the science and all the and geology, I don't know, whatever they want to do on Mars, fine. But we have to take into account that we're sending humans, not robots. So that needs to be reflected in the design. Okay. Then my question is, will it make any difference who we will be sending for these first missions? Will it make a difference? Well, whether that's, a international group with Japanese, European, American, South American, someone from Africa? Or do you say, no, that specificity for humans is not what we're saying. We're saying, humans have certain needs, all of them, regardless where you live. And that will influence that design. And also, will that be the first missions will already influence what's being built? Is that the aim? Because, the cities further away, wonderful, but let's not, waste time, I always think. What's your feeling about that? I see Alfredo nodding, so I'm starting with you today.
Sure. So I think architecture responds to a vision and to leadership, and obviously has a role in that leadership. So in that sense, I don't think it will set the right tone and the right roadmap to send a very homogeneous group to be the first ones living on Mars. So will the design change? Probably it will, but do we actually want to send people that are too homogeneous from the same country, same culture, same gender to Mars? I question if that is the right approach. So then the answer is probably we don't. Therefore, the design will incorporate that diversity that I think, and that's a very personal opinion, should be a must for a settlement on Mars, because again, Mars has to reflect the diversity that we have here on Earth.
Okay, it's a bit not perhaps nice to ask this of the two ladies, but do you feel that there should be a 50-50 male-female being sent to Mars? If we're talking about, designing and, people we send.
Michal, you want
to? Go ahead. Okay. I mean, I have a lot to say on this topic.
It is really interesting. In reality, physically, we are opposite sex, and we are, reproductive species. I mean, but today, when we send women to the ISS, apparently, we have to be contrary to our natural body function. Like, we can't have menstruation, and we have to be able to be like men, very strong and not really accommodated yet in terms of the entire design, like the suit. I mean, I'm sure that the way we will send the people to Mars, it will be a different chapter of our adaptation. Again, we were talking about a project in 2016 about extending our body function or elevating our body performance by having different external body parts as well that is integrated, so that we can actually function better in such extreme environment. But my suggestion to your question immediately, if we have to go tomorrow, I think Alfredo and Michal would agree with me that I would rather send my robotic avatar to Mars, my clone, so that it can express and perform the way I know to do here, but it will be my guinea pig, not having to sacrifice our life when we're not ready yet, but we can learn from it.
I would love to add that two things. One is that if we look at male versus female, there are a few researches that show that for deep space, for long duration missions, there is an advantage to sending women. They are physically and psychologically. Space blindness is one thing that is more prominent in men for long duration of flights because of the radiation, and also how you behave in group settings and things like that. But I would also want to add that on Earth, a lot of the things that were designed for men, because they were designed in times where women and other small minority groups didn't have rights for the land or to use the public space. And if we think about Mars, it's not really a question of who's going there first, but in general, if you want to make it more accessible, we have to prepare for many people, because if we design it for just the first group at the beginning, it will be harder for us to change things as we go along. And also the question is not only who will go first, but what will they go with? I think those things also will determine how at least the beginning of Mars architecture will look.
Okay. Now, of course, we go to Mars and we can't take everything with us. So we will have to use what's there, in situ resources. How do you think we will, what will be very good for us there and what will we really need to bring? Do you have any idea already in your designs? Vera.
Well, since I have been focusing on the architecture side, for example, we look at the abundant materials there. We have basalt that we have been looking at, and we're also looking at what is available as tools today to process that rocks to become filament of textile that we could use to make our clothings. Another thing that will be interesting is if we create some kind of system that we bring with our flight to accommodate plant-based construction quality of plants, or medicinal, or just like how the Aborigines at the beginning selected these plants to go from one continent to another. I think there is a lot we can learn from ancient, how humans deal with nature. It wouldn't be different. The only difference is that we have the advantage of new technologies that we will be able to make and adapt the in situ resource utilization plan to our convenience. This is why it's so important to see the planning a little bit farther ahead before we decide what we want to make.
Michal, what's your thought on that? Is there any specific material on Mars? I don't know, to make Roman concrete, I always think.
We can create a lot of materials from the elements that we have on Mars through different processes. I think Bjarke Ingels Group Big have an amazing kind of presentation about how we can recreate everything that we have here on Earth, basically, if we start from a certain point. I think that in the beginning, we will also be using the materials of the spacecrafts that we are coming with, or the humans will be coming with, to reuse them. Question if they are planning to go back to Earth, if they still need the spacecraft or not. But I think those are also parts of the materials. And also another thing, there can be many different considerations of materials. And if we think about, I told you that before a few days ago, if we think about all kinds of processes and technologies that will be sending there to produce oxygen and other things, we can have some sort of byproducts, or all of a sudden an abundance of some type of material that we didn't really think about that we'll be able to use, or we'll have to use if we want to be sustainable, and it can influence the way we build on Mars. So really, I think that there is no one right way to do architecture on Mars. And like Vera said, vernacular or organic architecture that is connected to nature happened all around the world in different ways. But today it will be very interesting to look how can those things happen with the technology and all the knowledge that we have.
Okay, Alfredo, your take on this.
More than materials, I would be more inclined to bring technology. Robotics, artificial intelligence will be critical in order to extract the resources that are already available on Mars. That goes back to what I was explaining before about self-sufficiency. You were asking about concrete on Mars. Based on the research that we did with the team of experts, it does not seem to be a most reasonable or sustainable or feasible solution. On the other way, steel is very easy to obtain. Again, easy question marks. The reason for that is that there is iron, a lot of iron in certain areas on Mars. We have a lot of CO2 and we have a lot of water. With the CO2 and the water, we can create chemical compositions, and then all of the above creates iron. So we do envision iron being the main material for structural and civil work, along with potential tunneling, as I explained before. But again, that we cannot really think that we are going to scale, and that's the word, scale, a settlement on Mars without being able to find the technology to actually leverage the many resources that Mars have. And obviously, we will need to bring seeds and farming because it's critical for the community to survive, and that will need to be brought from Earth. I can spend a lot of time talking about the specific materials, but I think that could give a fair summary of the solutions that we have.
Now, I would like to take some questions from the audience, and they keep coming in. And I think I hope that my panel will be, nice about it and be able to answer in chat or whatever follow-up questions after this session, which is nearly done. 2 questions about artificial lighting came in. Of course, this has to do with someone who worried about the vitamin D deficiency that we might get on Mars, but also someone who will it be, very harsh light? Will it be very, soft light? Because Mars has a different, it's a bit further from the sun. It has a different atmosphere. So the what it looks like, the light there is different. What will we do with that? Will we make it more Earth, more Mars? Artificial lighting. I'm starting with you again, Alfredo. Sorry about that.
That's perfect. So artificial lighting will be necessary on Mars. That is connected to the fact that anyone exposed to the sky on Mars will develop cancer. The radiation from the sun or from even the cosmic radiation is lethal. So we need to find indirect ways to bring the light, either with a reflection or with optic fibers, or with a technology that we have currently available on Earth and that we can develop over the next decades in order to ensure that the spaces that we have as habitable are comfortable for the well-being of humans, but at the same time, they are safe. That connects, as the question was asking, about complements. We are architects. We don't have expertise in medicine. In the team that we got on Sonnet, there were people that have a biotechnology background, and they were also indicating that the medicines or the core of the medicines could be developed also on Mars, thanks to the possibility to obtain carbon. Again, that goes back to the local resources. With carbon, we can start to generate the proper amount of materials that are not only for civil work, but also organics that we will be needing to survive and have a successful life on Mars.
Okay. Any of the ladies have anything to add? And
Yeah, I would love to add just really quickly that if we think about how we felt during COVID now in quarantine at home, humans need not only specific kind of light that maybe can imitate the sun, we need humidity and differences of temperatures in order to feel good. So definitely at the beginning, as I said in my presentation, everything will be also artificial. We have to create controlled environments. So not only the specific type of light or types of light, but also the humidity in the air, the oxygen, and all the other things. So I think in the beginning, at least, we will want to imitate conditions that we have on Earth, because we are just used to that, and that makes us feel good, physically, psychologically, emotionally. And I agree also with Alfredo, and it's something that we will definitely need as we go further into the future on Mars. If we'll do terraforming, if we'll do all kinds of processes, hopefully one day we'll be able to enjoy other types of lighting.
Now, I am very sorry, but we're at the end of the panel, and I see a slew of questions, and I myself have a slew of questions, because this is an interesting topic. It is talking about how will we live on our next planet. And so perhaps next year we will come back and we'll do another panel on this, because there's certainly enough material. I would like to thank my very learned panel on this subject for all their answers. And, I hope you, the public, will be able to reach out and ask your questions that weren't answered to them individually. Thank you so much.
Thank you so much. It was